So these were some of the particle assimilator devices. This was the first particle assimilator prototype. The problem with the first type was that it actually caused a lot of refraction occurring inside here. The silver paint was actually absorbing the light, and it was actually causing it to glow. And then I put more on it, and even though I did that, the light was being absorbed, which meant that it was somehow being turned to heat and still escaping. And there's absolutely nothing I could do about that. So I came to the conclusion that the photon's spin accelerating wouldn't exactly account for light color. So I'm going to have to move on out of that. And this is the same thing. It has, the idea is trying to control the spin, but instead this type, I actually used magnetic wire. Still the same thing occurred. I still am not getting rid of these two devices because they're pretty much history now. And then this is a different type of device. This one and this one is a different type of device. These two devices are actually made so that way they can transfer color. In this case, this one and this one. So what I'm going to do with these two is shine a laser. This is a needle. It's a really fine piece of metal, and it's a magnetic tube, and it's really tiny. And I'm going to shoot lasers through it and attempt to change the color of the laser light. So I'm going to eventually get three different colors of light: red, blue, and green, and fire the light through here. And what it's going to do is cut the waves up. So this one is going to attempt to use electromagnetic waves. I'm going to try to turn radio waves into light. And basically what that's going to look like is you're going to see it at first. It's going to be ionization, and then you're going to see a beam of light coming out, and then it should become brighter. So ions are going to turn into photons. That's the idea of these two devices. And this is the idea of how the idea looks. In this case, this is when matter becomes denser. And when matter becomes denser, it starts acting like particles. So what I believe is electrons look more like this and photons are more like this. So over a period of time, electrons emit their pressure, and an electron emits its pressure all at once. Its spin is all condensed down into one area, and a photon is circling like this through outer space, and an electron is circling like this through outer space. So the time density is much greater in an electron. So even though an electron and a photon would be roughly the same size, an electron would appear bigger because it's more energetic. And these are waves. So like if we say that this is red light, this is yellow light, and this is blue light. So in these waves, the red light is this size, and yellow light it's appearing in half as much time. And then the blue lights is appearing in half as much time as the yellow. So in this case, it's divided up into thirds, though it's not actually like that. They actually calculate the distance between the photons as nanometers or whatever. So how you would capture the light, and what I'm thinking of doing is actually using a triangle and measuring the curvature of the beam. If I can't tell the color, I'm going to measure the curvature, and that's going to tell me if it's actually changing if these are actually changing the light color. How our body actually detects it actually uses the speed of light it's like using a timer or a stopwatch in a race, and it's timing the photons to determine what type of photon it is. So it's the pressure of the photon, the reaction of the pressure. If this one's hitting it two times as fast, then it's going to go click, 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 and it's going to hit here. And then if it's moving 3 times as fast, it's going to go click, click, click. So it's going to react based on timing, and that's pretty much how our body tells us what color we're looking at, is the reaction time of the waves. And that's why we have different color sensors in our eyes. We actually have a red one, we actually have a yellow one, and we actually have a blue one. And then all of those little sensors in our eyeballs actually tell us the three colors that we can see in our spectrum. So I think I covered it. Yeah, so these two devices haven't been done yet, and these two are failed devices. This is different than this. These are particle assimilators, turning this type of photon into a denser photon into a denser one that you would see as an electron. So I'm saying that these things can be transferred and made denser and denser and denser until it comes down to matter. These ones are in particularly to make color change from red light into blue light into red light. That's those ideas. So I'm going to be able to expand these waves out or compress these waves, and that is going to make color. So these are color devices, and these are part of